Welcome back, everyone. In this section, we're going to talk about scientific notation. So oftentimes in science, we deal with numbers that are really, really big or numbers that are really, really small. For example, in order to calculate the gravitational force or the gravitational attraction between the Earth and the Sun, we need to know the mass of the Earth and the mass of the Sun. These values are huge numbers. So rather than write these as really large or really small numbers every time we're trying to write these out in equations or calculations, we use scientific notation. And scientific notation is a shorthand way of writing much larger numbers using exponents. So for example, let's start with a smaller number, like 300, and we're going to write that in scientific notation. Well, 300 is the same thing as 3 times 100, or 3 times 10 squared. And so we write this as 3 times a power of 10. And we can write any number as some number times a power of 10. And so we can write any number in scientific notation. To write really large numbers in scientific notation, we take the decimal point, generally at the end of the number, and we move it left until it's behind the first digit. And then we count. However many decimal places we move, that's going to be our exponent, times 10 to some power. So for example, if we want to write the mass of the Earth, our decimal point is here, at the end. And so we're just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We're going to move the decimal point to behind the first number. And so 5.9736, and then times 10, and then we move the decimal place 24 places, so times 10 to the 24th kilograms. So let's try this again. The population of the United States in 2015, 322 million people. Our decimal place is here at the end. We're just going to move 1, 2, 3, 4, 5, 6, 7, 8 decimal places until it's behind the first number. And we have 3.22146 times 10 to the 8th people. We can also round this value to 2 decimal places like other numbers, 3.22 times 10 to the 8th. To convert the distance from the Earth to the Moon in miles to scientific notation, our decimal point here at the end, we're just going to move 1, 2, 3, 4, 5 decimal places. 2.389 times 10 to the 5th miles. To convert small numbers, we're just going to move the decimal point in the opposite direction, and that's going to make our exponents negative. So here for the diameter of a hydrogen atom, now we have this decimal point. We want to move it to behind the first number that's not a 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so the diameter of a hydrogen atom, 2.50 times 10 to the negative 11 meters. So a really big number will have a positive exponent. A really small number will have a negative exponent. If we want to write these numbers in scientific notation, the weight of 1 grain of spruce pollen, here's our decimal point. We're going to move it to the right, 1, 2, 3, 4, 5 places until it's behind the first non-zero digit, 7 times 10 to the minus 5 grams. The average number of hours it took the U.S. government to spend $1 million in 2012. We want to convert this to scientific notation. Again, we would just move this decimal place to behind the very first non-zero digit, 2.1605 times 10 to the minus 3 hours. And if we rounded to 2 decimal places, 2.16 times 10 to the minus 3 hours. So let's just practice this. A, 0.0098. We're going to move the decimal place to the right, 1, 2, 3. That's 9.8 times 10 to the minus 3. For B, 1,478. Our decimal point is at the end. We're going to move to the left, 1, 2, 3 until it's behind the first number. 1.478 times 10 to the positive 3. 54,302,000. Again, our decimal point is at the end. And so we're going to move to the left 1, 2, 3, 4, 5, 6, 7 places. 5.4302 times 10 to the 7th. And for D, 0.000058, we're going to move 1, 2, 3, 4, 5, 6 places to the right. 5.8 times 10 to the minus 6. And so these are these numbers written in scientific notation. Likewise, we want to be able to convert back from scientific notation to decimals or whole numbers when necessary. And so we're just going to reverse the process to convert from scientific notation to decimal notation. So if we want to write each one of these numbers in decimal notation, 9.085 times 10 to the 4th, that means we're going to take 9.085 and we're going to move the decimal place now to the right 4 places. 1, 2, 3, 4. Any gaps that are here, we're just going to fill in with zeros. So this is 90,850 drops. The mass of an average dust particle, 7.53 times 10 to the minus 10. So 7.53, we're going to move the decimal place to the left now because it's a negative exponent. We're going to move it to the left 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get 0.123456789 zeros. Let's practice this some more. 6.3 times 10 to the 7th. That's 6.3. We're going to move the decimal place to the right 7 places. 1, 2, 3, 4, 5, 6, 7. And then just fill in zeros. That'll give us 63 million. And then we can do the same for the other examples. 2.973 times 10 to the minus 3. Now, because it's negative, we're going to go to the left 3 places. 1, 2, 3. 0.002973. For C, 4.999 times 10 to the 5th. We're going to move the decimal point 5 places to the right. 3, 4, 5. So 4, and then we'll have 2 zeros after it. And then finally, 9.103 times 10 to the minus 6. We're going to move the decimal place 6 places to the left. That will give us a 9 with 5 zeros in front. 0.000009103. Finally, it's important to recognize scientific notation in Excel. So I'm going to pull Excel up here in just a minute and show you how to do a calculation. Recognize that the capital E in Excel is taking place of the times 10. So it's telling you that it's times 10 to that power. So if we had the mass of the Earth written in scientific notation, in Excel, it would be e to the positive 24, the mass of the Sun, the distance between the two, and the gravitational constant. So I'm going to switch to Excel and just show you how to multiply and divide these values. So here in Excel, I just want to show you how to multiply and divide values in scientific notation and how to enter values in scientific notation. Notice here we have the values from the table in our PowerPoint slides. If I remove one of these values, I'm just going to show you how you can type it in. 5.97 with a capital E plus 24. And then we hit enter. And we can see that this value is now going to recognize it as an exponent. Notice that sum will show you the number if it's not too big or too small. If we wanted to calculate the force of gravity between the Earth and the Sun, it's just equal to the product of the mass of the Earth times the mass of the Sun times the gravitational constant divided by the distance squared. So when you're multiplying values in scientific notation in Excel, you can treat them just like regular numbers that you multiply in Excel, and you'll still get the same answer. Please let me know if you have any questions.